Hello everyone. Good morning, students. Uh, Today we have to learn some properties on definite integral. Those will help us to solve the so many problems regarding definite integrals. By the integral calculus, we can calculate the total changes of an object as well as area bounded by the curves. So to find the area bounded by the curve, at this time integral rule is much. While solving in problems part, these properties will be most useful us. And among these seven properties, some four properties are the most important as well as most standard. In these properties, one essay type question you will get in the examination. Let's move for those properties, dears. Okay. The property number one is property number one. First, I write properties. Properties. In the properties, the first one will be integral of f of x dx from a to b equal to integral of f of x dx. First I will take, instead of x, first property should be a t dt, interchanging the variable. This is t with dt from a to b. This is my property number one. I will prove now how this property will be true. We know that second fundamental theorem in that indefinite integral, that is f of x dx from a to b is equal to f of b minus f of a. So many problems we have done on this formula. So that formula I will apply here. And otherwise just we can take the substitution. So better first we write in our proof I is equal to integral of f of x dx from a to b. F of x dx from a to b. I will replace the variable according to the RHS part, that is put x is equal to t. What is the derivative? That is dx is equal to dt. Also, this thing we learn in that indefinite in second exercise in substitution method. But here some intervals we have. This is completely related to a definite integral. That's why what we can do? We can replace our limits also. When x is equal to t, here when x is equal to lower limit a, at this time what upper limit, what we will get the variable t, so that we can replace in the case of x a, we will get t is equal to a. Similarly, the upper limit when x is equal to b, then variable t should be a b. There is no changes at all. Now I is equal to integral of x value should be a t, hence it is the f of t with the dx means dt. Lower limit is a, and t will be a. Low upper limit is b here. That time t value should be a b. I can write like b. Therefore, I have proved the property number one, integral of f of x dx from a to b is equal to integral of f of t dt from a to b. What do you learn by this property? It means if we replace any variable, compulsory you must change the limits also. This property will state us, if we replace the variable, we can also replace, we can change the limit also. So look, I replace x by some other variable. Here basically I choose one t, then derivative of x is dx, derivative of t is dt. When lower limit x is a, at this time t uses a. When upper limit is b, t uses b. Now take the LHS part, that is integral of f of x dx from a to b. replacement x equal to t, as usual dt from a to b. So many problems you have done substitution method problems from 7.2 exercise. There we did not get any limit. So after substitution, immediately we have to go for this step. We can replace the limit. Then we'll get the property. This property will state us when we were replacing the variable at this time, compulsory we have to change the limit. This is property number 1. Note it. Okay. Now I will move to the property number 2. Integral of f of x dx from a to b is equal to minus integral of f of x dx from b to a. Dear students, note this property. When we are interchanging the limit, lower limit should be here. Upper limit should be a lower limit. At this time, symbol will change. The value will changes by the sign. In case it will use a positive quantity, when we are interchanging, we will get the negative quantity. This is the A to B, this is the B to A. That's why sign will change. Now let us know about that property. This is property number 2. First, I will write the LHS part. I is equal to integral of f of x dx from a to b. Now we can apply that formula. Integral of f of x dx from a to b is equal to f of b minus f of a. This is our second fundamental theorem. So now I can write f of b minus it is f of a. Clear? Now I will take the minus sign common. We get f of a minus f of b. f of a minus f of b. Afterward, minus sign keep as g. Once you look at this one, integral of f of x dx from a to b be written f of b minus f of a. Means upper limit b, here f of b. Lower limit is a, here f of a. But at first I have a. Then how I can write this one? This a I should make it as a upper limit. This b should make it as a lower limit. Remaining function as well f of x. Therefore, what do you get? That is integral of f of x dx from a to b. This is our second property. Keep in mind, second property will gives an idea for us, that is when we are interchanging the limit, value will changes by its sign. Okay, this is property number 2. Now property number 3 is the most standard property. In competitive exams, so many problems we will get regarding the property number 3, like a modulus, sinum, whatever restricted function. Let us see about that property number 3. Property 3 is integral of f of x dx from a to b. How to split this one? Because somewhere the function will not integrable, that's why we can split the values. That's why we have to write it integral of a to c f of x dx plus integral of c to a b, that is upper limit is b, f of x dx. It means one more value I have chosen, that is c. C should lies between a and b. What is c? C should lies between a and b. For example, a is 1, b is 5. A is 1, b is 5. What we can feel, see? Any value lies between that. Okay? Now I will prove this property. First I will write LHS part. I is equal to integral of f of x dx from a to b. Clear? Now just we have to apply the same formula. I can write by using second fundamental theorem, that is integral of f of x dx from a to b can be written as f of b minus f of a, this value. So now I will balance by observing the RHS part. What I can write C. C means f of C identity. A means simply I can write f of A. Already I have minus f of A. And here plus B. That is f of B minus this is an f of C. This is an f of C. How I balance it? F of B as usual minus f of A also we have. Just I added and subtracted f of C. Now look at this one. F of C minus f of A. A to B f of x dx means f of B minus f of A. Reverse it. F of C minus f of A means how I can write? That is lower limit is A, upper limit is C, hence it is an f of x dx plus integral of here too. Lower limit is C, upper limit is B, then we can write f of x dx. This is my third property, that is integral of f of x dx from a to b is equal to integral of f of x dx from a to c plus integral of c to b f of x dx. The most standard property, many times this property we are applying on the modulus function. So many functions integral value did you get, but still you don't know how to calculate integral of modulus x. So that time you should remember this formula. This will give us the solution. Okay, this is the most standard formula in competitive exam. Next property number 4. Recently, many years they have asked the question regarding this fourth property in GE mean. This is also one more most standard property. So many problems we got from this property, that is integral of f of x dx from a to b. From this property onwards, in theory part also the proof is most important. Please note carefully. Integral of f of x dx, that is integral of f of a plus b minus x dx from a to b. Very simple proof. RHS only will give us the hint. LHS part I have only x, so modify it a plus b minus something. So that's why I will take the substitution method. Before that, I will write LHS part I is equal to integral of f of x dx from a to b. Here's RHS part, what I have in the place of x, a plus b minus x. So that you have to substitute instead by x, that is put x equal to a plus b minus t. We cannot substitute x equal to a plus b minus x. That is not possible. So x equal to some other variable, that is a plus b minus t according to the RHS. So now what is the derivative? Dx is equal to both constant derivative is 0, constant derivative is 0, and t derivative will be 1. Simply I can write instead of 1, that is dt. So finally I get dx is equal to minus dt. Dx by I can replace minus dt. What I suggested you, we can change compulsory the limit also. So I can write here when x is equal to, look, x is equal to a plus b minus t. Now we are going to find t value. So that x equal to how much? A. Then x is equal to a. What about t value? How I can write this one? X equal to a plus b minus t. T I will take on LHS side, a plus b minus x t. So x is equal to a. X is equal to a. What you will get for p? A plus b minus c. A cancel. P will be c. So I can write here when x equal to a, p will obtain b. Same case, when x is equal to upper limit is b, then what it will get for p? A plus b minus b. These two cancel, hence p value will obtain a. I can write when x is equal to upper limit b, then you will get p value is a. Okay. Now we can go through the property. Integral I is equal to integral of f of in the place of x, what I can take a plus b minus t. What type of dt you have? That is minus dt. Dx equal to minus dt. What is the upper limit? Lower limit a, then t will be b. In the place of a, b. In the place of b, we got a. I can write a. Now this becomes totally b to a. But in RHS part I have a to b. What I can do? Interchange. How I can interchange? I equal to integral of a to b. Integral of a to b. F of a plus b minus t with minus dt. Everyone know that in second property, when we are interchanging the limit, sign will change. So that I interchange it b to a, like a to b, I can write minus sign. But already here minus and this minus becomes a plus sign. So that a to b, f of a plus b minus t with dt. So now remember your first property, integral of f of x dx. What is that? Integral of f of x dx from a to b. How we can write integral of f of t dt from a to b. That property I will apply here. Hence I will get a to b integral of f of a plus b minus x with dx. Here I applied the property number 2. Here I applied the property number 1. So this is our required property. What this property will state as sum of the limit minus whatever variable is there. We have to take by using this property such related problem we can simplify. So sum of the limit minus variable. The most standard property this one is noted. Everywhere it is important. Regarding this property, we get the question in KCT as well as in mains, as well as this property also most important in theory part also. Okay. Next, I will move to the property number 5. That is two most standard as well as important. The next property will be property number 5. Integral of f of x dx from 0 to a. A compulsory lower limit should be 0, upper limit is anything, equal to integral of f of a minus x dx. This is the most important property in theory part everywhere. Most standard. From core property onwards, everything will be the most important. But proof is very simple. Look at this one. As usual, LHS part I will write integral of f of x dx from 0 to a. Okay. Now look at the RHS. According to the RHS, we go for replacement. But x is equal to a minus t. I will take. Hence dx is equal to a will be constant. The derivative is 0. Hence left remains minus dt. And this side, when x is equal to lower limit is 0, what will get for t? T will be how much? Here you can substitute or please can calculate. X equal to a minus t. T take this side, it will be a minus x. So that when x equal to 0, this is a minus 0 equal to a. When x is equal to upper limit is a, hence t equal to a minus a equal to 0. When x will be 0, t will get a. When x is equal to upper limit a, what will you get for t? T will be 0. Now go through that property. I is equal to integral of f of x value is how much? A minus t. What type of dt we have? That is minus dt. And lower limit is 0. At this time 0, we got a. When x equal to a, t value will be 0. Now interchanging the limit, make it like RHS. So interchanging a to 0 becomes 0 to a. This side f of a minus t and this is minus t. If I interchange the limit mean sign will change. This minus into minus becomes a plus sign, hence it is 0 to a f of a minus t dt. Here I applied the property number 2. Now I will apply the property number 1. That is 0 to a integral of f of a minus x dx. Interchanging the limit, that is the second property. And the variable replacement, that is the property number 1. In property number 1, you replaced the variable as well as you got the same limit. So that property I taken here. Instead of t, I written x along with the same limit. This is the one more, the most important property. Please note. Next, the next property will be property number 5. This is then property number 6. Integral of 0 to 2a f of x dx. This splitting will be how write integral of 0 to a, that is f of x dx, plus integral of 0 to a f of 2a minus x dx. This is also the most standard, but in theory part sometimes they will ask regarding this property. Now as well I will write I is equal to integral of 0 to 2a, that is f of x dx. According to the third property, what is our third property? Splitting integral of f of x dx from a to b. We written like integral of f of x dx from a to c plus integral of f of x dx from c to a. Like this we split. So how 0 to 2a, I will take middle value, that is a. So first I will go for 0 to a f of x dx, plus I will move from a to 2a, that is f of x dx. Everyone know that a completely lies between 0 to 2a. Now I equal to this first integral, I will write it as the only replacement we should take for second integral, that is replace or put x is equal to how it is 2a minus x. So I can write 2a minus t. Okay, this is dx is equal to constant derivative is 0, remains minus d. Now limit replacement when x is equal to the lower limit is a, what we will get for t roughly we calculate. We consider x equal to 2a minus t. T is taken on LHS side. This side we get 2a minus x. So when x is equal to lower limit is a, at this time t will be 2a minus a is a. When x is equal to 2a, t is equal to 2a minus 2a equal to 0. So that when x equal to a, what did you get for t? A. When x is equal to 2a, then t value becomes 0. Now replacement in second integral. First integral write as the I equal to integral of f of x dx from 0 to a, and look at here minus dt is there. Before itself I will write a minus sign. Integral of when x is a, what is t? A. When x is 2a, what is t? That is 0. Hence f of x value what we replace it? That is 2a minus t. Minus dt actually I can write, but already minus sign I consider here. Hence I will write minus of just dt. I equal to integral of f of x dx from 0 to a minus the side interchanging the limit, sign will change, minus becomes a plus sign, and 0 to a f of 2a minus t dt. Second property I have applied here. After that, I is equal to integral of f of x dx from 0 to a. Here, according to the first property, integral of f of 2a minus x dx from 0 to a. By the property number 1, we have to interchange the variable, we'll get the answer. Note it, please. Okay, next property will be same as this property, that is property number 7. This is property number 7. Integral of f of x dx from 0 to 2a, we have to write in two ways. The one way will be, one way is 2 times of integral of f of x dx from 0 to a. In this case, if what it is, f of 2a minus x equal to, when we are considering f of x. Now we'll get 0. At this case, f of 2a minus x will be minus f of x will obtain at this time. There are two cases are there. So let us see that property. Completely this property also having the same proof up to here. Note it, integral of 0 to 2a f of x dx. I split it by using the property number 3. 0 to a to 2a. I replace it in the second integral x by 2a minus t. We have to replace the variable, that's why derivative. X becomes a dx, t becomes a dt. Compulsory we have to interchange the limit according to the property number 1, so that when x is equal to a, t we got a. When x is equal to 2a, then obtain t equal to 0. The same values I have replaced here. Because of minus dt, I have taken minus sign here. Simply I written dt. When x equal to 2a minus t, I will consider, that's why I replace f of 2a minus t. And lower limit is a, t value also a, upper limit is 2a, we get 0, that's why I have written 0. After that, I will consider the property number 2, interchanging the limit, upper limit and lower limit. So sign will change, minus sign becomes a plus sign, because a lower limit becomes upper limit 0 becomes a lower limit. After that, by the property number 1, I have proved f of x dx plus integral of f of 2a minus x dx form. After that, what I can take, this is calling it as equation number 1. Now I will take some two cases, that is case number 1. Case number 1. What is that case number 1? What's the given? We can consider if f of 2a minus x value should be assumed plus f of x. Then what will get? I will take the equation 1, I is equal to integral of f of x dx from 0 to a plus integral of, I assume 2a minus x should be a x, like sine of 180 minus theta is how much? Sine theta. Like that assumption we need here, that is f of x dx from 0 to a. these two have the same term, so I can add I is equal to 2 times of integral of f of x dx from 0 to a. This is my case number 1. I'll move for case number 2. That is, what is case number 2? Case number 2 will be if f of 2a minus x, we have to consider minus f of x. Then what will obtain? Let us take equation number 1. I is equal to first integral we write as it is. Only our assumption in that second integral, this 2a minus x, what I consider minus f of x. So I can write minus f of x. Before only I taken minus sign, that is dx from 0 to a. These two terms are opposite in sign, may cancel, will obtain 0. Therefore, I is equal to 0 I get. This is the one more standard property. Integral of f of x dx from 0 to a, 2 times of f of x dx from 0 to a. Look, here 2a, here I get only a. When it is possible, when 2a minus x equal to f of x. When I will take these some problems regarding this property, and this time clearly you will understand how this property will rule. Okay, now 0 f of 2a minus x equal to minus f of x. This is also one more standard and expectable property in that theory examination, and problems will be important on all these properties. Please note it. After this property, one more remains. I will continue that one. Next, property number 8, the last property. Among these property only, we have to simplify the all kinds of problems. These are the most standard properties. Let us see that last one. That is property number 8, last one. Integral of f of x dx from minus a to a. Limit value is same, but symbols are different. Here negative, here positive. At this time, how we can write? There are two cases will arise. 2 times of integral of f of x dx from 0 to a, like previous property. Here case is different. Then f of x is even. F of x is even. What it means f of x is even? F of x is even means that is f of minus x will be plus f of x. Take an example. Sine of minus theta is minus sine theta. Cos of minus theta is plus cos theta. Cos of negative input will be as well cos of positive input. That is considering to be a even function. But sine will not possible. Sine of minus theta will gives us a minus sine theta. Now I will take a second case, that is 0 at this case when f of x is odd. In such property to get the problem in just you can determine the function whether it is an even or odd. How to determine? Replace x by minus x. After that you verify whether it will get a plus f of x or not. So that is I will take here odd means f of negative input can be like that, f of minus x is equal to minus f of x. So as well, LHS part I will write, the LHS part can be written as I is equal to integral of, that is f of x dx from minus a to plus a. Here too we have to split it, negative to positive means we have to cross cos 0. That value I can take for splitting, that is minus a to 0 f of x dx plus 0 to a f of x dx. This step I have written by applying the property number 3, a to c, c to b, c lies between a and b. Here 0 lies between minus a and plus a. Now this property keep as it is, only you have to replace for this one, so that what I can take That is, I means put x is equal to what I can take these cases we can arise minus x. That's why x equal to minus t I will take, hence dx will become minus dt. Replacement when x is equal to lower limit minus a, what you will get 40. Here I replace the minus a, minus will cancel, t will obtain plus a. After that, when x is equal to upper limit 0, then what will obtain 40? Here we can substitute 0. X equal to 0 means t will give us 0. We are substituting only in the first integral. So that I is equal to what I can write integral of f of minus t I have chosen minus dt. Here I will write that minus sign, simply here dt. Then lower limit minus a, I get t value should be a. Then upper limit 0, I get same 0. Second integral, write as it is, don't disturb for that. Integral of f of x dx from 0 to a. Apply the property number to interchange the limit, then symbol will change, minus sign becomes a plus sign when I will interchange it, and this value as well minus t dt plus integral of f of x dx from 0 to a. Once you have to apply the property number 2, property number 1. Property number 1, that is integral of f of minus x dx, variable interchanging, limit also as well, and this side plus integral of f of x dx from 0 to a. This is equation number 1. Here some cases will arise, that is case number 1. What is that case number 1? When minus f of minus x equal to plus f of x. This is the first assumption. You can consider f of x is even. F of x is even or taken condition f of minus x equal to plus f of x. I can write this integral I is equal to integral of f of how much it is minus x should be plus f of x with dx from 0 to a. Remaining integral right as is integral of f of x dx from 0 to a. Look at this one, completely same. So we can add it 2 times of integral of f of x dx from 0 to a. When the function is even, then we write 2 times of integral of 0 to f of x dx instead of minus a. Now, case number 2. This is case number 2. What is that case number 2? We can assume like when x is equal, when f of minus x equal to minus f of x. It means I am considering function is an odd. When function is odd, what case will get? That is, I is equal to integral of f of x dx from what f of x we assume? Minus f of x. So minus sign here, 0 here. Plus integral of f of x dx from 0 to a. Look at this one, f of x, same limit but opposite in sign. Make it cancel. You will get the value I is equal to 0. This is our property. The first property is integral of f of x dx from 0 to a equal to integral of f of t dt a to b. And second property will be interchange of the limit, sign will change. The property number 3 is a to c, c to b, that is splitting the limits. The property number 4 is sum of the limit minus that variable. And fifth property what we taken, f of x dx from 0 to 2a we have written like f of a plus b minus f of 2 cases we taken 2 times of integral of f of x dx from 0 to a, at this time f of 2a minus x equal to plus f of x. In case that will use a minus f of x means 0. Next property we have taken this one, when lower limit is a minus a, upper limit is a plus a, at this time 2 times of integral of f of x dx from 0 to a. At this case, f of x is even. In case f of x is odd, that will give us 0. These are the most standard basic properties we have in our definite integral. Please go through these properties along with proof. After that, we make a practice as a formula like we can apply in our problems part. Okay, dears. In the next class, we have to discuss all kinds of problems regarding these properties. Okay.